Okay, hi, IM2 student. Today we will start with our module 6.3, day 1. It's on interpreting vertex and standard form. Content standard. Student will be able to transform a quadratic function by replacing it with positive or negative values. Language objective. Student will work in pairs or small group to both give and listen to oral clues about graph of quadratic functions. Example 1 or explain 1. Identify quadratic function in standard form. If a function is quadratic, it can be represented by an equation of the form y equal to ax squared plus bx plus c, where a, b, and c are real numbers, and a cannot be a zero. This is called the standard form of a quadratic equation. So this is our standard form. The axis of symmetry of a quadratic equation in standard form is given by the equation x equal to negative b over 2a. The vertex of the quadratic function in standard form is given by the coordinate x equal to negative b over 2a, comma y is equal to the function f of negative b over 2a. Okay, so let's review what we learned from our previous module, right? So then in previous module we have the vertex form is that y equal to a x minus h quantity squared plus k. Okay, so this is also a quadratic function, but it's in the vertex form, because from here we know that the vertex is h and k. But then in the standard form, the vertex is in this form, so we have to solve for the vertex. Okay, so let's move to our next slides. Right, example 1. Determine whether the function represented by each equation is quadratic. If so, give the axis of symmetry and the coordinate of the vertex. So for example, we need to rewrite this equation. So then we say that this is y equal to negative 3x squared plus 0x, and there's not a 0, minus 4. So then our a is going to be a negative 3, b is going to be a 0, and c is a negative 4. Right? So rewrite the function in the form of y equal to ax squared plus bx plus c. So we say that this is negative 3x squared plus 0x minus 4. To compare that to, so this is a standard form of a quadratic equation. Okay, so if you see that y plus 3x squared equal to negative 4 is a quadratic function, give the axis of symmetry. Remember that the axis of symmetry is that x equal to negative b over 2a. So then this gives us negative 0 over 2 times negative 3. So 0 over negative 6 is still a 0. So the axis of symmetry x equal to a 0. And say that if y plus 3x squared equal to negative 4 is a quadratic function, give the coordinate of the vertex. So then we see that f of negative b over 2a, but then we see that b over 2a is a 0. So then this is f of, let me erase that, let me fix that. So this is f of 0, which means that we go back and write our function that a 0 squared plus 0 times 0 minus 4, so it's going to be a negative 4. So the vertex is going to be 0, negative 4, right? Okay. So see that number 3, explain why the function represented by the equation y equal to ax squared plus bx plus c is a quadratic only when a is not 0. Well, when a is not 0, that means that we have the x squared here. So this is y equal to ax squared plus bx plus c. So then the x squared tells us that it's a quadratic equation. Right? Number 4, why is it easier to determine whether a function is quadratic when it's expressed in function notation? Right? So function notation, we see that this is f of x equal to ax squared plus bx plus c. Okay? And how is the axis of symmetry related to the standard form? Well, our standard form that we see that x is equal to negative b over 2a. Right? So a is the leading coefficient, b is the coefficient for x. Okay, so for these two examples, determine whether the function represented by each equation is quadratic. Right? So here we can solve for y. So we say that y is equal to negative x squared plus 4x plus 0. So then a is a negative 1, b is 4, and c is a 0. So our axis of symmetry, x equal to negative 4 over 2 times negative 1. So be negative 4 over negative 2 reduced to 2. And our function f of 2 will give us 2 squared minus plus 4 times negative 2 plus 0. So this gives us negative 4 minus 8 plus 0 so equal to negative 12. So then the vertex is at 2, negative 12. At number 7, so solving for y, so we have 2y equal to 14x minus x plus 6. So 2y equal to 13x plus 6. Y equal to 13x plus 6 divided by 2. But then for x we do not have a square. So then this is not a quadratic. Okay, let's move on to our next one. So this is for you guys to try it. Determine if each function is a quadratic function. Okay. So for number 1, the answer is yes. So then it's a quadratic. Then we need to look for the axis of symmetry and the vertex coordinates. So then we say that x equal to negative 3 over 2 times 2. So it becomes 3 over 4. And the let me erase this part. So 3 over 4, so 3 over 4 squared minus 3 times 3 over 4 plus 5. So this gives us 2 times 9 over 16 minus 9 over 4 plus 5. And from here we can use our calculator to work this out. Or so let's do this by hand. We have so that 9 over 8 minus 9 over 4 plus 5. Okay, so this comes out to be 31 over 8. So then let me write here for the vertex. It's going to be 3 over 4 and 31 over 8. Right, so from number 2, since we don't have a square, so this is not a quadratic. And number 3, like y is to the power of x, so it's also not a quadratic. Okay, so let's try this again. Write each quadratic function in standard form and write the equation of the lines of symmetry. Right, so even though this equation looks kind of weird, but we have an x squared here, so let's rewrite this. So y equal to x squared plus x plus 2. So then always write it in standard form. So we know that a is 1, b is also 1, and c is 2. So then the axis of symmetry, x equal to negative b over 2a. So this gives us negative 1 over 2 times 1. So reduced to negative 1/2. And for number 5, it's similar to 4, so rewrite it in standard form. So y equal to negative x squared plus 2x minus 1. So the axis of symmetry, x equal to negative 2 over 2 times negative 1. So negative 2 over negative 2 is 1. Right? Similar to number 6, we write it in standard form, so we become negative 5x squared plus 2x minus 2. So the axis of symmetry, x equal to negative 2 over 2 times negative 5. So reduce to 1/5. Okay? Right. So then example 2 change from vertex form to standard form. It is possible to write quadratic equation in various forms. Rewrite the quadratic function from vertex form y equal to a times the quantity of x minus x quantity squared plus k to standard form y equal to ax squared plus bx plus c. Okay, so here we want to write from the vertex form to a standard form. So since this is a square, that means that we take x plus 2 times x plus 2, right? So let's work this out. So it gives us x squared plus 2x plus another 2x plus 4. So we're using a FOIL, right? So this is negative 3 times x squared plus 4x plus 4 minus 1. And then now we need to distribute this 3 into every one of these. So this gives us a negative 3x squared minus 12x minus 12. And then there's the minus 1, so then combine like terms, so we have a negative 3x squared minus 12x minus 13. Okay, so then this is our standard form, right? So we see that the standard form of the vertex form is negative 3x squared minus 12x minus 13, right? Okay, so we see that if in y equal to a quantity x minus x quantity squared plus k, where a equal to 1, what is the simplified form of the standard form? Okay, so let's go through some of our examples. So we write a quadratic function from the vertex form to standard form. Okay, so this is 2. So then expand this out. So then give us x plus 5 times x plus 5. Okay, make sure that this stay as a group, and then plus 3 on the outside. So do FOIL with this. So this is 2 times x squared plus 10x plus 25, and then plus 3. And now distribute the 2 in first before you add in the 3. So give us 2x squared plus 20x plus 50 plus 3. And then so the standard form will be 2x squared plus 20x plus 53. Right? And for number 10, so we have a negative 3 x minus 7 times x minus 7 plus 2. So this is negative 3 times x squared minus 14x plus 49, and then plus 2 at the end. So disputing the negative 3. So 1 plus 2 and 42x plus 27, 12, so 147, and then plus 2, so give us a negative minus 6 again, so this is a negative. So negative 3x squared plus 42x, and a negative, so give us a negative 147. Let me change that. Okay, so now you guys are going to try this. Going to change the vertex form into a standard form. Okay. Right. Same here. Alright. Okay, so that's the end of our 6.3 day 1. We have our bookwork and we have our new HRW, and I need you to copy down 6.3 day 2 as well. Alright guys, so have a good day and be safe.